Hi, good day. So today, briefly, I was speaking on interpolation. Right. So as stated in this document, says given a set of measured data, say n plus 1 pairs, in this format, x naught, y naught, uh, x naught, y naught, x1, y1, down to xn, yn. Okay. Right. So it says the problem of interpolation is to find a function f of x such that f of xi here is equal to yi. And then for I equals 0, 1, and so the aim is for us to have f of x1 equal to y, and say for f of x2 equals to y2, and then to f of xn equals to yn. So that's the aim of interpolation. Define a function f of x such that f of xi is equal to yi. Now in this function interpolation, we call this a node. So the xi is called node, and f of x set interpolates theta and it's called interpolation function. So in this setting, interpolation function, provided f of xi equals yi, we call this an interpolation function. So interpolation function will be f of x. So if it's if you're interpolating for I equals 2, so f of x2 called interpolation function. So the first line says f of x is set to approximate g of x if we data from function g of x. So let me just turn this up. Alright, so those things are just things you should take note of. As I said, to interpolate or extrapolate if f of x gives values within. So if it gives values within this range, within this boundary, then it's called to interpolate. If it gives values outside, and it's set to extrapolate. So I'll move down to the next slide quickly. So there is an example here. Alright, so for a polynomial of degree n, say let's say degree 2, right? Let's say polynomial of degree 2. So what we have is a formula we're going to use interpolation function. The interpolation function as stated in the figure right here. Okay. So interpolation function. So interpolation function, come on. As the interpolation function of f of x equals Pn of x, n where n is the degree. So if degree is 2, we have f of x equals P2 of x equals a0 plus a1x plus a2x squared plus a n(xn). So if it's a degree, if it's degree 2, we once we get to the power of n such that n is 2, we have x squared. We stop right here. So our interpolation function showing the f of x equals P2 of x equals a0 plus a1x plus a2x squared. So it stops there. But for any degree n, that's why we have this case here. So if you are dealing with whether it's 3 or 4 or 5, it's going to be dependent on this same formula. So if the a0, say, let's assume n is 5. So we have P5 of x equals a0 plus a1x plus a2x squared, and then a3 x cubed, a4 as it progresses to a5 x5. Alright, so now looking at Lagrangian polynomials. So fitting 2 points. Now we are putting 2 points on the graph. Set fit the linear polynomial for 2 given points x0, y1, x1, y1, and this is basically a linear polynomial. So how does this work? Say we have a point 1 which is x1, y0, and the second point is x1, y1. So the polynomial, right? Lagrangian polynomial for this is p1 of x, right? Because L naught x y naught plus L1 x y1. So L1 x y1 as stated here. So how does the Lagrangian polynomial work? This is how it works. So we have x1 minus and x1 to find L naught. Now pick sorry. pick y naught, right? Pick y naught. This is a trick to finding out how to find any Lagrangian any Lagrangian polynomial for any degree you are working with. So once you have y naught, you click y naught, right? And then pick y naught, put it aside, then you have x minus this, right? And x naught minus this, right? So that's how you find for this part for y naught. Now for L1, for L naught, you have right here. You pick y naught, right? Then you subtract this from x, right? And that is this. Subtract this from x. So that is 1. So you have x minus x1. X minus, sorry. You have x minus x1 over x naught minus x1. Right, that is L naught. Then the y naught, there is L naught x y naught. So you have y naught, right? So L naught x y naught, so you have this right here, and you put y naught behind it. So for L1 now, we're going to use the same format we used. So what you basically do is so L1, right? Then you do x minus x naught divided by x1 minus x naught, right? So that's L1. So that's basically how to get the Lagrangian polynomial. So for L naught you do pick y naught x minus x1, x0 minus x1, right? Then for y1, for the y1 you pick y1, put it aside, then you do x minus x naught, then x1 minus x naught. Then because our formula says p1 of x equals L naught x plus L naught x y naught plus L1 x y1. So basically once you've gotten your L naught, you just put y naught behind it, then plus x naught x minus x naught, which is L1, and then you put y1 behind it. So that is your polynomial, the linear polynomial for two given points. Yes, so now remember wondering how they came up with the y naught here. So they said p1 of x naught equals y naught, right? So basically this is of degree 1, right? So we have p1 of x naught equals y1. How they come about this? So since our our polynomial is x minus x1 over x naught minus x1, right? Y naught plus this, right? Sorry, x minus x naught over x1 x naught. So we have this. What we do is anywhere we find x, we substitute it for x naught. So here we have x, we change this to x naught. So we have x naught minus x1 over x naught minus x1, right? Into what? Y naught plus, remember anywhere we have x, we substitute for x naught. So x naught over x1 minus x naught into y1. So it's quite easily done. Y1. So basically this is going to give you 1. They basically divide themselves to get 1. So you get 1 y naught. I just put it that way to be as simple as possible. Plus this x naught minus x naught to give you 0. 0 divided by this, sorry. X naught minus x naught will give you 0. So 0 divided by this will always give you 0. So 0 times y eventually is going to give you 0. So basically 1 times y naught is y naught, and your answer is y naught. That is why p1 of x naught is y naught. So the same thing goes for p1 of x1. How do we get y1? The same way. We just basically changed x to x1. So basically we changed this guy, right, to x1. So let's assume we have x1 here, right, and we have x1 here. So what do we have? We have x1 and x1, which give you 0. 0 divided by this will give you 0. 0 times y naught to give you 0. Everything becomes 0 plus x1 minus x0, x1 minus x1 minus x1 minus x0 divided by x1 minus x1 gives you 1. So 0 plus 1 y1, that is y1. So that's how we got this. There's really nothing much to it. So basically just know how the Lagrangian polynomial works. Follow that sequence I gave you earlier. So how you pick this x minus this, then x minus this, then how you pick this x minus this and x minus this. So let that quickly move to the next slide. So say we are fitting 3 points now. The last one we're fitting 2 points, and then the last one we had it was the polynomial was just was for a degree of just 1. Now we are working with 3 points, and this is how this will work. I'll just explain briefly. So let's say the first point is x, right? Okay, so we have x1, right? Okay, we have x0, right? Y0, x1, y1, x2, y2, and these are 3 points. So the same way it works, we said p 1 of the x, right? Is L naught x y naught plus L 1x y1. But now we're dealing with P2, right? We're dealing with a quadratic polynomial, which means it's of degree 2. So what we have here is L naught x y naught plus L1x y1 plus L2, sorry, 2x y2. So this will be our, what we can, I'm trying to avoid using paint because paint is very unexpected. Maybe I actually switch paint. There we go. Yeah. Right. So basically that's the so I said L naught x y naught plus L1 x y1 plus L2 x y2. So now to find L naught, I said we're fitting for 3 points: x naught, y naught, x1, y1, and x2, y2. So how does this work? Remember, pick y naught, right? Pick y naught. Then do x minus x1, right? You could just do this y naught into x minus x1, right? Then x minus x2 divided by then x naught minus this and x naught minus this, right? So come on. So we have x naught minus x1 and x naught minus x2, and that's for this first part. Now for the second one, we have y1, right? So pick y1 now. Let me erase this guy a little bit. Let me erase this guy. Sorry. Okay. Position that. Yeah. Okay. So okay. I'm back. So this is not messing. This is as y naught. I think I'm. So for y1, you pick y1, right? And this is to pick. I think I'm going to pause this right now. Okay, so basically, okay, so for y1, you pick y1, then you do x minus x naught, right? Then x minus x2. So x minus x naught into x minus x2 divided by x1 minus x naught multiplied by x naught, x1 rather, minus x2. So that is for the second part. Then for the third one, which is y2, I said I'm fitting 3 points. So we are going to have something very similar. So it's going to be, I'm going to pick y2, right? Once you pick y2, you now do x minus x1, right? Then x minus x0. You do x minus x1 multiplied by x minus x0, then divided by what is beside y1. You have x2, so x2 minus x1, x2 minus x0. So if you follow this closely, you find out that it is very similar to what we have here, right? So let's be sure that's what we have. So we have x minus x1, x minus x2. I think this is very good. So this is our this is our interpolation. This is our interpolation function, right? For this, right? So interpolation function is set to, so to solve this, we have an example here. Okay, we have an example. Okay. Basically, this is how to get interpolation function for any for 3 points. So the last one we thought was one for when we are putting 2 points. Alright, so how did they get this guy here? Okay. So this is very similar, the same way we did the first one. They basically put x as x0. We put x as x0 to get something similar. So let's just test for this. So you know how they came up with these answers below. With this, I'm considering this now. So how did they get 1, 0, 0? How did it work? So they put x as x0. So let's put x0 here, right? And x0 here. Let's get x0 here. Sorry. Yeah. Okay. So x as x0, 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 x0. So what do we have there? X minus x0, x minus x. This is 1, I believe, because they will divide evenly. We have 1 minus plus this is going to give us x1 minus x0, which is 0, divided by, so multiplied by x1 minus x2. Anything multiplied by 0 will give you 0, and it's anything divided by 0 will still give you 0. So we have 0 plus what we have here, x1 minus x0, to give you 0. This one divide it by 0 and still get 0. So what we have is y0, right? So we have 1 minus, right? Rather, we have 1 here, right? We have 1. We have we have 1 here. We're gonna have 1 in this place. We're gonna have 0. We're gonna have 0 here. This is where we have this 1, 0, 0. So for L0 of x, we have 1 here. L1 of x, we have 0. L2 of x, we have 0, right? So where x is what? X0. So for the case where we have L0 of x as x1, right? So where we have x as x1. So let me erase this. So let me back to this quickly. So say we are meant to consider this as and wherever we have x equals x1, let's do x1 here, x1, 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 x1. So how does this work? This one give you 0, right? 0 times this gives you 0. That's why you have 0 here. For this side there, we have x1 minus x0, x1 minus x2. Right? Is that right? Okay. Sorry. We have x1, x1. Okay, x1 minus x minus x2. Since we have divided this, we are going to divide evenly and we get 1 here. And for here, we are going to have x1 minus x0. X1 minus what? X1 minus x1. So we have 0 here. 0 multiplied this, everything eventually here becomes because it's divided by 0. So we have 0, 1, 0. So just follow that pattern, right? You realize that that's how they got this. But this is major. These questions like this were hardly asked. What you should focus on is how to apply this your this in your interpolation function or polynomial as a way, how to use to solve problems. So that's what we're doing right now. Quickly. So here you are putting n plus 1 point. So for whatever number of points you're using, basically what you'll be having is you better have L0 x plus L1 x L0 x y 0 plus L1 x y1 plus L2 x y2, then dot with L to be to Ln of x y, or let me say Lk of x y k. That'll be like for any number of points, right? That's like a so basically these are things you just know. So it's saying for k equals 0 to n, right? Lk x y k. So if k is 1, L no L1 x y 1, k is 2, L2 x y 2. I'm speaking about this now. Then it extends like and it just goes on like that. So basically all we're discussing about was just explicitly stated there. So for any data set x1 y1, p of x equals y1. And note, remember the aim of interpolation is to ensure that for any point x of xi is equal to yi, right? So for here, basically, once you pick y, once you have for any simple data set like this, p of x equals y1, right? We have here, so where you pick y1 and you say x minus x2, sorry, x minus x2, right? Divided by x1 minus x2, right? And pick y2, you say x minus x1 divided by x2 minus x1. That was confusing. Right? Alright, so it continues like that. It goes on for any degree of any degree you get. So whether it's degree 1, degree 2, or degree 3, whether it's p1 of x, p1 of p2 of x, which is degree 2, p3 of x, p3 of degree 3. So it goes on and on. So we have an example here. So we have a data set here, minus 1, minus 4. This is the first point. For the second point, 0, minus 5. And the third point, 1 and minus 2. So let's call this one here. Let's just consider it as x1, right? Let this be x0, y0, x1, y1, x2, y2. Remember I said it. Pick minus 4 and put it out, right? So we have this L0 x y0 plus L1 x1 plus L2 x y2. And so we have y naught, we're going to do x minus x1, x minus x1, x minus that by x minus x2. So x minus x1, which is 0, x minus 0, x minus x2, which is 1. We have x minus 1, right? Then it continues like that, divided by x0 minus x1, multiplied by x1 minus x2. x1 minus 1, x2 is sorry, x1 minus x1, x0 minus 1, right? And x1 is 0. So we have minus 1 minus 0 multiplied by x0 minus x2, which is minus 1 minus 1. So you have this. You do the same for the second part here. When you pick out y1, you have minus 5. Put it out and do x minus x0 multiplied by x minus x2. So you have x minus 1, that's x plus 1, right? Then x minus x minus 1, right? This is where we have this. Then the same sequence continues. You follow the order and eventually you get this, right? You get everything here. And when you have this, you now have to simplify. So basically what we did there was x minus 0, x minus 1 multiply, that's x squared minus x, that's minus 0, this is 0 basically, then minus 0, whatever. So x squared minus x is what you eventually get. So when you have this, this one is going to be minus 1 minus 0, minus 1 minus 1, minus 1 minus 0 is minus 1 times minus 2. That gives you 2, right? So we have minus 4 into x squared minus x over 2. Make this simple for yourself. Like bring out 2, you have minus 4 over 2 into x squared minus x, right? So that's how that was generated. Right, so same for this, you simplify this x plus 1, x minus 1, oh, sorry, plus 1, x minus 1. Simplify this, you have x squared minus x plus x minus 1, right? So minus x plus x, takes 0 out, right? So we have x squared minus 1. And like I said there, 0 plus 1, that's 1. 0 minus 0 minus 1. 1 times minus 1 gives you minus 1. You have x minus 1 over 1. That's when you have 5 multiplying this. So basically make it simple for yourself. Minus 5 divided by minus 1. Minus 5 will just come out. over minus 1, then you put x squared minus 1. This will basically give you 5, right? Simple. So same thing works for this. Expand this, you have x squared. You have x squared. We're gonna have x squared plus x, right? So this is what you get. And then expand this, you have 1 plus 1, 2, 2 multiplied by 1, you have 2. So once you get this, right, all you need to do is simplify this. Now you simplify this minus 5, 5 minus 1 gives you 5, minus 2 divided by 2 gives you minus 1. Let me make it simple, like let's keep a couple of steps. So sort of make it simple so you get the concept. So you have minus 4 divided by minus 2, that's minus 2, right? X squared minus x plus that's 5 into x squared minus 1 plus minus 1, right? X squared plus x. Clean this off. Squared. So minus 2x squared minus plus 2x plus 5x squared minus 5 plus and minus x squared minus x, right? So this is basically what you get. And once you get this, you simplify again and you get this, right? So how do you arrive at this? You have then 2x squared minus 5x squared minus. So we have then 2x minus x due to x, right? And then minus 2x squared minus x squared gives you minus 3x squared. As 5x squared minus 2x squared gives you 2x squared. This is how we got this. So eventually when they say plug in the values of x, right? So said let's try where x is equal to 1. So substitute x as 1 here. So you have minus 1 rather. So you have minus 1 squared divided by 2, which is 2, plus substitute for x here as 1 and as minus 1 rather. So you have minus 1 minus 5. Evaluate that to get this. So do the same for when x is 0, right? So our interpolation function or polynomial as well. Once you get that, you now ask you to plug the values into it. That's how much of this question go. So let me see the next slide. And this is basically giving us same thing we had before for how we work with the Lagrangian polynomial. Remember where we have for I equals y right? Where we have y naught, then we are doing that. I equals 1 to m, j equals 1 to m. So the way it works is x minus xj, right? So let's say j is 1, x minus x1 into x and 1 minus x1. Basically, it is it's what we resolved the last time. Let me spend too much time on this because what you can just do is help yourself like this. Just know this, but since you already know how to solve the problem of keeping y naught, right? Then doing x minus what is x minus x1, that sequence we had the last time. So work with that. That's basically what this is explaining for like the Lagrangian polynomial. And then this is a very different method. The next video I'll be talking about it. But basically, we're talking about Lagrangian transformation polynomial. The aim is that f of xi equals to yi, right? So you should not have much problem with this. So I'm still going to do something now. I'm going to open up the semester of this course. Just the question. So given this table, right? So, come on. So is that giving this table? Come on. Yeah. So given this table, we're still construct the Lagrange interpolating polynomial P2 of x, right? So I'm looking for Lagrange interpolating polynomial, which is a quadratic polynomial for the degree of 2, right? So how do we do it? Now, remember the aim, right? The aim is to have a function f of xi, right? So that to have a function f of xi equals yi, right? So let me analyze this. You say the degree of interpolation polynomial is 2, and you know x naught, x1, x2, right? So remember, let me get this. Let me just go. So remember, let's assume for this way. Let's actually evaluate. We're not really assuming anything yet. We have x naught, y naught, x1, y1, x2, y2. Remember, I've said degree 2, right? So degree of 2, p2 of x. So you said this p2 of x interpolate f3, right? Interpolate that's the f3 chart. So I'll get to that. So nodes are x naught, x1, x2, where x naught is 2, x1 is 2.5, and x2 is 4. So now the functional values, don't get confused too much with this. It's saying f naught is 1 over 2, 1 over f1 is 1 over 2.5, and f2 is 1 over 4. So what this is basically saying is that we have f right naught, f of x naught, alright, is 1 over 2, right? F of x naught equals 1 over 2.5. F of x2 equals what? 1 over 4. Remember, f of xi, y equals 0, 1, 2, and so on. Remember, f of x naught, we got it down last. F of xi equals yi, right? So this f of x naught, which is 1 over 2, is the same thing as what? Y naught. So this same one, f of x1, which 1 over 2.5, equals to y1, and this f of x2, which 1 over 4, is equal to y2. So if we are to construct our Lagrangian interpolation polynomial now, which is p2 of x, right, equal to what? L naught of what? X y naught plus L1 of x y1 plus L2 of x y2. We are going to have our y naught as what? 1 over 2. Y1 as what? 1 over 2.5. And y2 as what? 1 over 4. Right? So don't be confused with the functional values f naught, f1, f whatever. So that's basically how you construct a polynomial. Then you solve using that same order we discussed last. The other part, you solve using that same. You solve using that same formula we use. L naught of x equals what? X minus. Then remember, you have to multiply by y naught at the end. Then get your L1 and multiply by y1. Get your L2 and multiply by y2. And once you finally get this, your interpolation function, you impute f, you put 3 as x. Anywhere you find x, you put 3. So that's how this works, right? So anywhere you find x, you impute it as 3. So once you get that, you're going to get this answer. I'll stick with it. Just try it, solve and validate. But I'm sure you work with this background polynomial. So L naught of x, y naught. They're giving us most of the things we need. L1 of x, y1, then L2 of x, y2. So let me see, is there anything I need to regard this question? Okay, so our nodes. I think I spoke about the nodes already. Remember our nodes. I spoke about the nodes, yeah. But then our set, our data set has another thing. X1, X0, Y0, X1, Y0, X2, Y2. So what's our X0 here? It has been given. X0 is 2. So 2, you have 2 comma, what's Y0? Y0 is F0, right? That's 1 over 2. X1 is what? X1 is 2.5. Y1 is what? And that's Y1. Y1 is 2.5, really. 1 over 2.5, so that's 1 over 2.5. Then X2 is what? 4. Y2 is what? 1 over 4. So this is what you'll be working with. Data set you're going to be working with. 3 points. That's the data set you're going to be working with. So these are 3 points you work with, and then try to solve using those values. This is your data set, your X0, your Y0, Y1, Y2 are given already as your F0, F1, F2. Remember, f of xi equals to yi. So f of xi, say F0, right, is equal to what? Y0. So that's how it works. And then your L0, your L1, your L2, you know how to work with that and that's it. I think that's all for this question. Basically, Lagrangian polynomial, I'm done with that. So I'm moving next to Newton's divided difference method. Thank you very much.